Hey guys, and welcome back to your channel. Today I want to open a brief parenthesis to talk about complex numbers. You know, the imaginary ones. Hi again, this is Frank, and if you have not done so already, go ahead and subscribe to my channel to get more contents like this one. Today I'm going to be introducing complex numbers. And the first thing to talk about here is the imaginary unit, usually written as I. I here is going to be equal to the square root of -1, which means that if you square I, you would get -1. And so this particular unit is the core of complex numbers. If you write the number without the imaginary unit I, the number would simply be a real number. In a standard form, a complex number is written as A plus BI, where A is the real part of the complex number and B is the imaginary part of the complex number. And here is not BI, it's just B, that is the imaginary part. And so you should know that every real number is actually a complex number with the imaginary part B being equal to 0. And so you could also represent a complex number in a complex plane. So for instance, the standard form A plus BI can be represented as a point P of coordinate AB, the real part and the imaginary part. So if you have to plot this point on the complex plane, not the real plane this time, you would have to put two axes here, not the X and Y axis, but instead the real axis and the imaginary axis. And so you could have your point P right here of coordinate AB. Now, two complex numbers are said to be equal if their real parts are equal to each other and their imaginary parts are equal to each other. Both of those conditions have to meet for the complex number to be equal. And so how do you actually operate in complex number? How do you add, multiply, divide, or even simplify them? And so let's go through some examples here so we can see how that works out. My first example here is going to be the addition of two complex numbers. The first complex number is going to be 5 plus 6i. And the second complex number is going to be 7 minus 2i. Obviously, those two complex numbers are not equal to each other because their real part or the imaginary part are different. 5 is different from 7, and 6 is different from -2. And so to add them together, all you have to do here is add the real part together and then add the imaginary part together. And so you're going to have here 5 plus 7, that's going to give us 12, and then plus 6 minus 2, that's going to give us 4. And so you're going to have 12 plus 4i, and that will be it for the addition of complex number. You will do the same thing with the subtraction of complex number. So for instance, if I gave you -2 minus 2i minus 3 plus 4i, you would have to subtract their real part and then subtract their imaginary part. And so you're going to have -2 minus 3, that's going to give us -5. And then you're going to have -2 minus 4, which is going to give us -6i. So in a way, when you're adding or subtracting complex number, the I is sitting there as a variable. Okay, so how do you multiply them? Let me give you an example here. Let's say you have the complex number 4i multiplied by the complex number 3 plus 2i. And so what you have to do here is the same thing you've been doing ever since. You're going to have to FOIL out this particular expression. And so you're going to have 4i multiplied by 3. That's going to give us 12i. And then you're going to have 4i multiplied by 2i. That's going to give us 8i squared. And so our 12i is going to remain, but the I squared in front of the 8 is going to become -1. And so you're going to have here -8. And finally, you can write this complex number in a standard form, starting with the real part, then the imaginary part. And so you could have -8 plus 12i. Let me give you another example here for multiplication. Let's say you have the complex number 7 plus 2i multiplied by the complex number 2 minus 3i. And so you're going to have to FOIL it again. And so 7 times 2 is going to give us 14. 7 times 3i is going to give us 21i negative. And then 2i times 2 would give us 4i. And finally, 2 minus 3 is going to give us 6 negative. And then we're going to have I squared on the side here. And so now you're going to have 14. And then the middle terms here, 21i and 4i would subtract together and then give you -17i. And finally at the end here, the I squared is seen as -1. And so that's going to make the -6i squared just equal to 6 positive. And so you're going to have 14 plus 6 equal to 20 minus 17i. And you're done for this one. So how do you go about dividing complex numbers? For an example, let's say you have the complex number 7 plus 4i divided by the complex number 2 minus 5i. Okay, so to divide complex number, what you have to do is look at the bottom complex number and multiply the top and bottom by its conjugate. And the conjugate of the complex number is simply the same exact number, but with the imaginary part flipped from either positive to negative or negative to positive. Basically, you have to change the sign of the imaginary part. And so in this case, the conjugate of 2 minus 5i is going to be 2 plus 5i. And so I'm going to multiply top and bottom by that number. And then once that's done, I can go ahead and FOIL the numerator and the denominator. And so that's going to give me on top 7 times 2 is 14, and then 7 times 5 is 35, and then 4 times 2 is 8, and then 4 times 5 is 20i squared. And on the bottom, I'm going to have 2 times 2 is 4, then 2 times 5i is going to give me 10i, and then negative 5i times 2 is going to give me negative 10i, and finally 5i and 5i will give me 25i squared negative. And then you can go ahead and simplify this. Notice that the reason why we are doing the conjugate on the top and the bottom is because on the bottom here, you're going to have the middle terms here plus or minus cancel each other. And since I squared is equal to negative 1, you're going to have on the bottom here just 4 plus 25, which is the same thing as 29. And on the top, we're going to go ahead and combine all the real part and imaginary part. So 20i squared on the end here is the same thing as negative 20. And so we're going to have 14 minus 20 giving us negative 6. And on the middle here, 35 plus 8 would give us 43i. And so you can have our final answer here as negative 6 divided by 29 plus 43 divided by 29i. Okay, so let me give you another example so you can have this concept just sink in. Let's say I gave you the complex number negative 6i divided by the complex number 3 plus 2i. So since this is division, what we have to do is multiply the numerator and denominator by the conjugate of the denominator. And so that's going to give us the numerator multiplied by 3 minus 2i and the denominator multiplied by 3 minus 2i as well. And so foiling the numerator and denominator, we're going to get 6i times 3, giving us 18i, and 6i times negative 2i, giving us 12, because I times I is negative, cancelling the other negative next to the 2. And on the bottom, we're going to have 3 times 3 is 9, and then 3 times negative 2i is negative 6i, 2i times 3 is 6i, and finally, 2i times negative 2i would give us 4, because the i's square cancel out the negative in front of the 2i again. And so finally, on the bottom here, you got the middle terms here canceling again. And so on the top, you're going to get 12 plus 18i, and on the bottom, you're going to get 13. And so our final answer here is going to be 12 over 13 plus 18 over 13i. Okay, so let me give you two unusual examples that you might see coming up when you deal with complex numbers. The first one is going to be negative 6 minus the square root of negative 12 divided by 48. Now, in this example here, the complex number is not visible, but it's there. The negative inside the root here can be taken out as I, and so you can write this expression as negative 6 minus I root 12 divided by 48. And we can take out the negative as I here because remember at the beginning, I is the same thing as the square root of negative 1. And so after that, I can go ahead and rewrite this as negative 6 divided by 48 minus I times 2 root 3 divided by 48, because 12 is 4 times 3, and 4 can come out of the root as 2. Finally, I can simplify it further and write this number as negative 1 over 8 for the real part minus I square root of 3 over 24 for the imaginary part. Last example, let's say you're given the number 3 square root of negative 5 multiplied by the number negative 4 square root of negative 12. That's going to give us 3 root 5, and then the I can come out because that's the square root of negative 1. And then the other expression is going to be written as negative 4 times I 2 root 3, because I again can come out of the root because that's the square root of -1, and the 12 can be written as 2 times the root of 3, just like before. And so now I can finally simplify this further and combine all the numbers together. And so I'm going to have here the I and the I would become I squared, which is going to become -1, canceling the negative in front of the 4. So that's all gone. And then 3 times 4 times 2 would give us 24. And finally, I can combine the square root number. And so I'm going to have 5 times 3 giving me 15 under the square root. And with that, we are done. And as always, if you would like a copy of this note, check out the descriptions below. And if you like the way I break down the material, give me a thumbs up, and I will see you in the next one. Bye-bye.